All right, so what we'll do is we'll do a review for the test tomorrow on 4.4 through 5.4, part 1. So the first thing we looked at this week was square roots, okay? Looking at domain, range, solving square root equations, and graphing them. Let's start out with just kind of a simple solve. Okay, so let's say we had square root of x plus 6 equals 5. Okay, so generally the goal when you have a square root equation is to get the root by itself. In this case it already is. So what would we have to do to both sides? Yep.
Square both sides.
Yep. Square both sides. Square and square root cancel. And on the left that'll leave me with x plus 6. And then on the right, 25. And last step. Subtract 6 from each side. 25 minus 6. Get 19. Now, do we have to check that, or is that always going to work? We do have to check it. It could be extraneous. In this case, it won't be. It does work. But if you plug it back in, you get 19 plus 6 is 25, and the square root of 25 is 5. It would have been extraneous if I just changed one thing to that. Okay? So in that case, when you square both sides, you get the same second step. But the problem is when you plug 19 into that to check it, you would get 5 equals negative 5. Okay, so it would not work in this case. So any questions on that? Okay, so that's the first one that's similar to what's... Alright, so the second one we're going to look at is a graph. So the idea, remember, for a graph is if you have an even root, there's a starting point and then it goes in one direction. If it's an odd root, the graph goes in both directions. So let's try graphing 3 square root of x plus 2 minus 5. Okay, so first of all, is this the kind of graph that it goes in one direction or both? One, yeah, just goes in one direction. So the first thing you want to do is figure out where the starting point would be. Now, if you didn't shift it, where would the starting point have been originally? If we didn't do any of that stuff to it and just looked at the basic function. Yeah, it would have been at the origin. So now we need to figure out where the starting point is. So take the radicand, set it equal to 0, and solve it. So when you solve that, what do you get for x? Yeah, you get negative 2, which should make sense because if you had a point at the origin and you shifted it left 2, which is what that's doing, the point 0, 0 would move left 2. But not only are we moving it left 2, we're also moving up and down. So there's my x. Now plug that back in and let's get the y. So negative 2 plus 2 gives me 0, square root of 0, times 3. So really none of that matters, but then 0 minus 5, negative 5. All right, so that's going to be the point that we start with. Now from there we have to decide, do we pick values that are bigger than negative 2 for x, or do we pick values that are smaller? If we go the wrong way, we're going to get imaginaries. So Tessa, what do you think here? Would I pick numbers bigger than negative 2 to plug in for x, or smaller? Yeah, we've got to go bigger, okay? Because if you plug in smaller, like try negative 10, you'd get an imaginary number when you take the square root of a negative. So let's pick some ones that are easy for us to do. Let's do negative 1. Negative 1 plus 2 gives me 1. And what's the square root of 1? 1 times 3. And 3 minus 5. Negative 2. All right, let's do... actually, you tell me, what would be another x value we could do in our head? 2 would be good, yep. 2 plus 2 is 4. Square root of 4 is 2. Times 3 is 6. 6 minus 5 gives me 1. You can always use your calculator if you have trouble and just make the table, but I mean, we can do it this way too. And I think one more good value would probably be, let's do 7. 7 plus 2 gives me 9, square root of 9. And then 3 times 3 is 9, take away 5. 4. So those points will probably be good enough to make a sketch. All right, so let's get a graph. Let's start with -2, -5. All right, we got -1, -2, 2, 1. What else? 7, 4. Okay, so I can see the curve pretty good from that graph. So our function goes up, and it goes in that direction forever. Remember, that is a starting point, so it does not go any lower than that. It does not go to the left of that. And that's it. That's your sketch. Any questions on how we sketch that? Only thing you would have done different for an odd root is you would have had to pick numbers on both sides of the starting point, because it would have looked more like that shape. Okay. If you put a negative either in front of the x or in front of the 3, what does a negative cause the graph to do? It can reflect. Yep. So this graph could be reflected so that it goes that way, or it could also be reflected so it goes another way too. You could put the negative in front of the 3 or in front of the x. I don't want to complicate the one we just did. Okay.
How do you, like, with an odd one, how do you, I don't know, do an odd one? Like, how do you solve it?
So you still do the same thing. You're gonna make the start point by setting the radicand equal to 0, and then plug that value back in to get the y value. But then from there, when you make a table, let's say your starting point was this, -2, -5, you would have to pick numbers bigger than -2 like we did here, but then you'd also have to pick some that are smaller, like -5, because it goes both ways. Yep. You just have to pick x's on each side. Okay. Any other questions on that one? All right, so while we're doing that, let's actually use that same graph. And let's describe the transformations. So we have 3 square root of x plus 2 minus 5. So assuming that this is our base that we're going to compare everything to, Tessa, how many transformations are happening to turn square root of x into what we have there?
3.
Yep, there's 3. And Rebecca, could you tell me the first number that I would focus on?
The +2.
Yep, the +2. And Tessa, what's the +2 going to do?
Well, it shifted left 2.
Yep, it's going to shift left 2. The next thing we're going to look at is the 3. What's the 3 going to do?
Stretch it vertically.
Yep, by how much?
3.
Yeah, so vertical stretch by factor of 3. And then the last thing we're going to look at is the -5. And what will the -5 do?
Will it shift it
Yeah, down 5, yep. So shift down 5. So the only thing well, a couple things it didn't have. It didn't have a horizontal stretch. That would have been if you put a number in front of x that wasn't a 1. And it didn't have any reflections. If you put a negative in front of the x, that would be a horizontal reflection, which is over the y-axis. If you put a negative in front of the 3, that would be a vertical reflection, which is over the x.
If it's like a cube root, does the 3 do anything? Like
No, the only difference would be if that was a cube root, now you'd be comparing everything to the cube root of x, and the answer would be exactly the same. Yep. All right. Okay, so the next one is going to be having to do with exponential growth. Okay. Let's say we start with 6 cells, whatever, 6 bacteria, six something, and it's going to double every month. I want to know how many months would have to go by before we have 200 cells. So how long before we have 200 cells? All right, so we want to first set up our equation. Okay, do you remember how the equation starts for something doubling? Yep.
The initial amount.
Yep.
Times 2 to the t.
And one more thing we need. Actually, no, in this case we wouldn't. Because normally we put t divided by the length of time to double, but the length of time to double is every, even though it's not written, it's implied every month is every 1 month. So just, I guess for completeness, I'll put it so you can see it. And now we want to know when we're going to have 200 cells. So would we plug that in for A of t or t? A of t, that's an amount. So fill that in. And now you can't simplify that right-hand side. Don't try to do 6 times 2. You can't do that. So let's graph it and see what happens. So 200 cells. We'll see you later, Colleen.
Thank you.
So 6 times 2. Probably going to need parentheses around that if the denominator was something other than 1. It's not even really important to put it this time because it's just a 1. The smallest number of months that could go by would be 0. If it's doubling every month, I think it's going to hit 200 pretty quick. Right? Definitely within 10 months because it will have doubled 10 times, so it's probably going to hit 200. What's the smallest number of bacteria we have? 6. We want to know when we hit 200, so we'll go to 250. So we're going to have 200 bacteria wherever they cross. So intersect after about a little over 5 months. So it's going to take about 5.1 months. Great. Any questions on that one? So the next one, I think it was either your class or the other class asked me about one in the homework, which was something like this. Let's say 4 to 2x minus 5 equals 16. So, did we look at the one like this in your class? The one in the homework where we had to rewrite one of the sides in terms of or rewrite both sides using exponents? So, how can you rewrite each side so that we basically can get the bases to be the same? 16 doesn't look like a base, but pretend that it's 16 to the first.
Well, you have to get like the exponent the same and the base the same. Right?
Yeah, start by getting the base the same. So is there any way you could rewrite this and that so they use the same base?
Can you get 4?
Right.
4 squared? Or
Well, we gotta write something that's still equivalent to the number 4. So what's another way to write 4?
2 squared.
Sure, you could do that. So 2 squared. And how could you rewrite 16? And you have to write it with the same base you picked on the other side. So you picked 2 as a base on the left, so you got to do 2 to some power on the right.
Maybe 2 to the 4th.
Yeah, 2 to the 4th. Now, on the left, you have a power raised to another power. What do you do when you have a power to a power? What you do with the 2 powers?
Don't you have to distribute?
Yeah, you multiply them. And because it's a little more complicated expression, you do end up having to distribute. So that's 2 to the 4x minus 10 equals 2 to the 4. So now you've made the bases match. What else has to match?
The exponent.
Yeah, the exponents. So make that equal to that. So, and if I solve it, I get 4x, subtract 10 from each side, negative 6. So what does x come out to here?
Negative 3 halves.
Yeah, you could put negative 6/4, or if you reduce that, negative 3/2. So that problem was set up special so that you could do it by writing each number with the same base. If I change that 16 to a 17, now it's going to be a lot harder. Any questions on that? What else? We have that. Now I think the rest of the test gets into logs. Right, so I'm going to have you solving different types of log equations. And let's say I gave you something like log, let's put the variable in the base, base x. Of, let's say, 12 equals 5. Great. So we have an equation there. What format is that? Log form or exponential?
Log.
Log. So the only option we have is let's try changing it to exponential and see what happens. Okay. How would we rewrite that as exponential? Start with our base. What would be the base? Yep, x. What would be my exponent? 5. And what would go on the other side? 12. Now we have x to the 5th, so we need to undo raising to the 5th power. So what could you do to both sides that would get rid of the 5th power?
Do both sides to the 5th root.
Yeah, take the 5th root of both sides. 5th root, 5th power cancels out. And now we just have to type that in. Okay, so to type that in, start with your index. 5, math, and then the 5th option down is the xth root, and then it'll fill that in for the index, and then type in 12. Okay, so you should get about 1.2 0.64. Okay, so any questions on solving a log equation where the variable is in the base? Okay, that usually ends up taking a root of both sides at some point. Right, let's try one where the variable is in the argument. So let's say we had log base 3 of x equals 4. All right, so I'm going to start off the same way. Okay, is that a log equation or exponential? Log, yep. So let's rewrite it as an exponential and see what we have to do from there. Rebecca, what's my base here?
3.
Yep, 3. And the exponent?
4.
4. And the only thing you haven't used?
X.
X. Now that one, even simpler than the last one, it's just a matter of typing in 3 to the 4th power, which is,
8.
that's 3 to the 3rd power. Right, because 3 times 3 is 9, times 3 is 27, I'm wrong. 3 times 4 is 81. Yep, 3 to the 4th is 81. Okay. So that's solving one where the variable is the argument. So we did the base, we did the argument. Let's try it where it's on the other side. Let's do log base 5 of 125. Now it could say just, instead of saying solve, on this kind of problem, it could say like simplify. Well, if it's confusing to look at it as a simplify, turn it into a solve. Put equals something. We don't know what it equals. And now do the same thing we just did before. Tessa, what would I get if I change that to exponential?
You would have 5 as the base,
Yep.
and then the x as the top part,
Yep, as your exponent.
and then 125.
And 125. Now this one I had to pick numbers that would work out nicely. So what power would you raise 5 to get 125?
3.
3. Yep. So you get 3. Okay, so any questions on solving where the variable's on the other side? All right. What else? How about any questions with negatives? Not a negative argument or a negative base, but if I gave you a problem and I had a negative on the other side. Because remember, that's always your exponent. So if that becomes negative, what does a negative exponent do?
Doesn't it make it a fraction?
Yeah, it makes it a fraction. It flips it. So like if you had 2 to the negative 3rd, that means 1 divided by. Okay, so if you see negative exponent, that's going to flip it. So in this case, if I made that a negative 4, your answer would have been 1 divided by 81. Would have flipped it. Let's see. Okay, another bacteria one with something doubling. Another equation we solved similar to that. And I think that's pretty much it. So I think that covers one of each type of what's similar to what's on the test.
Are there any ones that like you combine? Like
Oh, the logarithms? Yeah, I am going to give probably a bonus question since we just did that today on either combining or splitting logs. Yep. Did you want me to make up one of those?
Well, I already did the homework.
Yep.
And number 33, I wanted to, I don't know how to do really.
Yeah, let's take a look at it. All right, so let's look at how we would split that up. First of all, inside the brackets, do you have a product or a quotient?
Product.
Yeah, product, you're multiplying. And you're multiplying three things together. The 5,000, the x, and the 1 plus r to the 360. So when we split it, it's going to split into three logarithms. And because it's a product, does that split as a sum or difference?
As
Yep, it's going to be a sum. And even though they didn't put it, what's the base on all those logs?
10.
Right, they're assuming it's a 10. What's the argument to my first log?
5,000.
5,000. Okay, argument to my second log?
X.
X. And what about my third log?
Would it be 1 plus r?
Yep, so it would be 1 plus r, and the exponent would have been 360, but where are you going to put that?
In front.
In front. Yep. And that's it. That's all you can really do with that. So there'll be some kind of bonus question, kind of like that, combining or splitting logs. Okay, any other questions?